Thank you. Can you hear the back? Okay.
Bit louder. Anyway, welcome. I'm really embedded software developer, so I think most of you have more experience than me in KiCad. So it's also pretty much about KiCad and yeah, the new interface to the plugins. Just by show of hands, how many of you have developed plugin for KiCad? We no here. Okay.
Yeah. So, and anyone try the new IPC plugin interface? Yeah. Okay. So one.
So yeah, I'm not going to go into why do you need plugins, but I'm first going to sort of have a very quick look between the old and the new interface. What does it look like and what's the difference? And then I'm going to look at the architecture of the new interface because that is really a big shift from the old to the new.
When I'll be brave and have a demo, I think everyone's avoided having a demo up to this point.
But I will both, and then I'll sort of go in reverse and have a demo first, and then look at the code, and then look at how to get started. So I'll find it a more interesting stuff in the beginning. I'll try to make it very short, 20 minutes or so, and then we can have some time for questions. So, yeah. First of all, the old interface. The old interface, if you look at it from a technical point of view, was really a direct call from the plugin into the code itself. So this was a very close, tight connection. And that is why on a lot of versions, when you change the version, it actually broke the interface because this was closely to their actual code. And once they changed the code, the interface actually changed. So at the end, it supported Python. So the new interface, they really split like a big split between the application, KiCad, and the plugin. Okay. So these were really two independent applications running now. And then they communicate with each other using sockets. Or this communication use MNG and protobuf. I'm not going to go into exactly at ease. But each one of these actually running an environment. So if you look at the old API, they ran a custom Python interpreter inside KiCad actually. So every time they will use KiCad, they compiled a Python version per KiCad. The new one, it will be completely separate. So if you run your plugin, this will actually run your system Python. Okay. So there's a little bit of responsibility to the user now where we have to install our own Python. So because this is an independent process, it actually gives people the opportunity to write plugins in other languages as well, which I think is important. Obviously, I'll stick with Python. So this is just sort of a very simplified way of representing how Linear is going to work, where you have your KiCad on the one side, and you have your plugin in one side, and then you basically send messages using your sockets in your application. So I'll start off with a demo. So you will see that this is a very simple hello world demo. Okay, so the only thing it's going to do is it's going to place a hello world on the PCB. Okay. If I can find the mouse. So when you install a plugin, you actually get the new icon. In this case, this is just the icon. And when I place it, you should see text somewhere around there, I hope. And we don't, because it placed it out of screen. Let me move this. So I'm going to move this, and when I press it again, it should rise up there. Allows. And there it is. Okay. So this is just very simple. So let's look at what do you need to do this. So the first thing when you work in Python is you have to import whatever you need, and you might have to import some additional components. In the case of a plugin, you import KiCad. So the first step will be to actually establish this connection to KiCad. And for that, it's just simple to call to KiCad and you get a reference state. And once you have a reference to KiCad, you must get the access to a PCB in KiCad. Okay. So one thing that I didn't mention is you must have KiCad open. So if you don't have KiCad open, this will fail. The next thing you want is you want to get some information on your PCB. So it depends really on what you want to do. In most cases, I think you might want to manipulate your PCB components. So to do that, you do a call to get blueprints. But you might also want to do some other things, well, for example, getting the tracks, getting the meds, all that is selected. And for each one of those, you have a different way. So once you have access to these components, you can loop over them in this case, and I'll quickly show if you want to extract some information on these components. So I've written a small blueprint function, and this will simply print the reference field text value, which is your references that we used to, like R1 or IC1 or whatever symbol you was assigned to a component. And then you can look at, for example, the position or which layer it is on. Okay, so this is just extracting information. You can also look at the paths because you have multiple paths on each blueprint. So yeah, I'm just going to quickly go through this. You can go pad by pad. You can look at the type, the position. Where it is oriented at. Now you can go ahead and you can actually change this position of your component. And for that, there's a built-in vector tool, which is just the X and the Y position, really. And you can assign this footprint position to the new position. What is interesting about the coordinate system in KiCad is that it's not what we used to. The top left is actually position 0, so Y positive goes down. Okay. I know in the new KiCad you can save it in your options, or it's still gonna be in reverse in your API queries. Okay, so that's just a little bit confusing in the beginning, but you get used to it. Also, the measurements is in nanometers. So if you want to use different units, you have to do a conversion. There is built-in conversion for millimeters if you want to use millimeters. The other thing that's important is to make the different layers. So internally, the layers are really numbers, and they've conveniently supplied enumerated tabs for the different layers. In those codes, in this example, is basically board lower front soft screen and board lower packet copper again. Similarly to pricing something, we can move it, but overlay the plus equals operator. So you just give the keys that you want to move it and assign it to the position. Or you can add something like we did in the now. So you can import whatever component or item you want to add. In this case, broad text. You create it with the broad text function call, or you could do something like adding a track by creating any track. So once you've created this item, you actually want to set up some parameters for it. In this case, hello KiCad plugin in the text field. You want to set the position, which is, as you can see, in millimeters in this case. And you want to set up which port level you want to use. And silk screen. Similarly, you can set up tracks with start and end positions and so on. So once you've actually created or changed your components, you want to connect this to KiCad. Okay. And the way that KiCad does this is similar to Git version control, where we'll have a commit and you actually do a push of your commit. Right. So there you set up your commit. You will give it a list of all the changes, actually, of all the components you have created in this case. And then you do a push commit to actually send it through to KiCad. Okay. So this is if you created components, and slightly different if you have modified components. And the reason for that is that it should actually match up your changes to what's internal. Okay. So in that case, you also do a begin commit, but you don't do a create items, you do an update items. And then once again, you do a push commit. So one thing that's interesting is that you could actually have multiple steps that you do in a commit all at the same time. Okay. How it influences the user on the user side is this will all be combined into one undo. So whatever you do in your plugin, the louver can actually undo with Ctrl Z, whatever key are you using for that. Okay. But it also means that you can split up your operations into multiple undo steps. So in some cases, it might be convenient if the user can just do certain steps and undo them one at a time. This is simply several steps combined. So with these string commands, you can actually add something on your board. So if I want to summarize the flow, you basically do a setup, which is getting a reference to your KiCad and getting a reference to the PCB. You do your operations, your business logic, as software people call it, and what you want to do on the PCB, and then you commit them. So I'm quickly gonna try another demo. And this one is really just the code that I've shown earlier. They are just print out information of the components on the PCB. Okay, so this is not going to do anything on the PCB. What I am also showing in this case is the previous one. I ran the plugin directly from KiCad. In this case, I'm actually running it as a separate process in a terminal. Okay. So you have the different options. You can run your plugin from within KiCad, but you can also run it completely separately. So this one will simply print out a list of
what's going on with the components. Scroll up a bit.
So what you will see is UT value 1, sorry.
It will tell how many pads it's got. The name of the net
Connected to this pad, the type of the pad, and this is if it's through or SMB or something like that. The position, offset, size, and so on,
each pad. And you can also see on which layer it is.
So you can get information from exactly what is in it, but this is just for inspection, really.
Yeah, so that basically concludes the Python side of it. Now, how do you actually get this into
KiCad, into application itself? Well, for installation, it actually, for a plugin, you need through a 4 files, depending on what it is. For Python, you need 4 files. And before you do anything, you have to do install of your package that you want to use, which is KiCad Python. And if you ask the AI about it, it gets very confused because the package name and what you import is different. Okay, so be aware the install is KiCad Python while the import is KiPy. Then you can use any development environment you really comfortable with in Python. So you can use
PyCharm or VS Code or command line.
So you have a lot of flexibility in your development environment. Once again, note it requires KiCad PCB to be open. Okay. So to do a install of this plugin, you need a pull files, as I mentioned. These files are plugin.json, and this is a JSON file that specifies to KiCad what is actually going on. I'll look at it in a little bit more detail.
You have your application files, which is your Python files.
And in those cases, you want an icon that's on the top right in the example. So these files, you basically copy all 3 of them. There's a 4th one that I'll get to just now. But you copy these into the KiCad plugin folder.
This folder is different for the different platforms. This is for Linux.
You have a unique plugin name. So you inside this local shares KiCad plugins, you actually create a new folder. Okay. So all files should be in this folder. You have to restart KiCad, and KiCad is basically when it starts up, it will check in that folder if there is a new file, and it will install it for you. Okay. So it fails silently. If it fails, it doesn't say anything. Okay. So you not have to debug it,
which I'll get to later. But this is a typical
files that you need for your build. There's one that I didn't mention, and that's the requirements that text file. And once it's developed with
Python, knows that normally you put your packages that you're going to use in there.
So in your plugin JSON, you have to sort of fill in, give the information to KiCad that you want kind of plugin. Obviously, you must give it a name. You must also give it a unique identifier, but it can be anything as far as I know anyway.
You must specify the runtime. For Python, it will always be Python. And then actions. So actions is what buttons you want on the screen. And for the button, you must give it a name. You must give it a scope. And the scope in this case defines if it's in the PCB or in the e-schematic. Okay. At this point, only PCB is supported, so it will always be PCB. And you specify an entry point, and the entry point is the file name of your script. And lastly, just an icon. 2 icons actually, but they can be the same. So if you wanted to travel, this is the magic key I found. You basically tell on into a terminal, you set up these environment variables, which tells KiCad to print out more debug information, and you run KiCad. Yeah, I'm slowly running out of time. But if you want your own user interface, you can really use any user interface, Python user interface you want. You can use Qt or in most cases, WS Windows, which is what KiCad's using. There are some limitations. As I said, it's PCB only, so only for the PCB editor and not for schematic yet. The PCB must be open. Is a CLI interface, a command line interface that they're working on. You must enable the IPC explicitly. That's an interesting one. So you cannot use the new plugins by default in version 9. You have to enable it in the options. And then it must be Python 3.9 to 3.12. And obviously, it's still a work in progress. So you can expect some problems. Yeah. Where's dinner? So what I'm going to do in this demo is basically place the components and move them around a little bit. So I'm also going to show how you can do development. So I'm using VS Code, and this is my Python code. So I've placed a breakpoint in my code, and when I'm just going to run it interactively in the debugger. So where I hit the breakpoint, now I can step into Wookie. Here you will see getting the reference to KiCad. There and then, get the board from KiCad. And then I'm going to do some operations in the background. I'm not going to go through them step by step. So now that routine has moved the components around. These components, as you see, I'm basically just going to rearrange them. Okay. So there I do my begin commit. I'll place them. And now when I do the update, it should update them. And once I do the collect, you should see these components should be rearranged. Somewhere it's rearranged. Okay, so that's it, basically, as far as the very simple plugin development wise. That's the QR code for the Git repository for examples and for the presentation. So yes, that's it. I can go keyboard.
So, thanks for the great talk. Does KiCad create a virtual environment for each role in and install the requirements automatically?
Yeah. Okay. I'm also not sure about the answer, and I've actually asked Wayne about it yesterday. So, I don't know if you understand the question. He's basically asking me have multiple plugins. Do they have their own individual environment, or if it's like at one will they share the same environment? Okay, I understand it correctly. So, the answer is that, as I understand it, this one anyways, that are really independent from each other. So, in theory, you can actually run 2 or 3 Python plugins, and they will each have their own virtual environment. Okay, so you can actually run different versions of Python for different plugins that you have. Okay, this is very tricky to do. I can tell you that as well, because you have the user is now responsible for installing the different Python plugins, Python versions. Sorry. Okay, so yes, it is possible. I don't know if it's that practical. Yeah.
Yes, the new API is genius. So nice that we have that. But I have a few drawbacks. One large drawback is if I supply a plugin via the plugin manager and the API is not activated, the user see nothing. If there exists some hacky way to tell the user here it is not working, can't install it because it doesn't do anything.
100%.
Could I ask another question?
Now let me just finish as well as here, if it's okay. Can I just answer one? Yeah, sure. Okay. So, if I rephrase the question slightly, is if you want a new plugin, it basically just nothing. It just the user doesn't see anything. So if you give it to the user, he eventually nothing happens. Okay, and he doesn't know why. Right? It's very frustrating. And the reason why is, as I said earlier, you have to enable the new API explicitly in the settings. I understand your question correctly. Okay, so I understand, and I haven't tested this yet, but in the latest release 9.04, I think it's already enabled, but it's definitely going to come in the newer releases. If you try to run a new plugin, it will tell you that the option is not set. So it's not going to do it for you, it's just going to follow the user that it's not set.
That is also nice because current situation is that the user see nothing until the code is broken. Yeah, you don't become any messages also if you start it over the terminal. The other part is what I have a problem is with the graphical user interface it makes more fun, yeah, definitely. But these instances are separated from KiCad, and in principle you can start the graphical user interface as often if you would like. So natively there is no support that you see there exists an open graphical user interface or an open connection. Is it somehow possible to see the open IPC connections, or could it be possible? That would be extremely helpful.
I can understand, I'll agree with you, but I don't think so. Sorry, what? He's asking if there is a background plugin running, it can be hidden from the user, correct? Yeah. It can be hidden, it can either be in the background, or even if he's on his own user interface, this might be hidden behind the screen and the user doesn't know what's going on. And I think this question has been asked before on the forum, and nobody really had an answer for how this should be handled. But it is definitely a problem.
Yeah, what I have done is a own IPC server to find my instance, and that's not so nice.
Was so we run a process check in the background. Yes, it's a good way of doing it, but it's awkward. Yes.
Yeah, hi. So what happens if you don't follow the proper commit protocol? So like you send an update command without having created a commit, or you exit before you commit the commit, or you begin a commit that you don't like push, and then you begin another one.
Okay, yeah. So if you so because there's already two independent processes. Now I'm guessing a little bit, but I mean the commit was like a git commit, really, same idea. So the actual data will only be sent when you do the commit. So if you don't do a commit, nothing is going to happen. But there is one thing that I did not mention. When you do the updates, it will actually return a list of components or actions, whatever you want to call it. And this might not actually match what you have committed. Okay. And the reason why is if you look at this at the more lower technical level, within KiCad, they have the event queue. Okay. This event queue, all events, and that includes user events, and I think it also includes events between the PCB and the schematic. Okay. It all goes into this event queue. And this event queue then execute whatever is in the queue. Okay. And the reason for this is to keep consistency in the data structure. So in this case, you might ask it for the components, and someone might go and actually delete some of those components in the background, or you sort of manipulating them on the one side. Or when you commit them, that component's gone. Okay. And that is why when you get a return, it might not be all components in it anymore. So in theory, you should verify, but I think most people are not going to worry about it too much. If people, I don't expect anyone working on the PCB to go and delete something in the background. So.
My question is concerning the board. You told us that at the moment only the board is supported for plugins. Are there any plans to include the schematics for plugins?
Planning on supporting schematic.
Yes, that I could do maybe create a plugin for the schematic side.
Yeah, I know it all planning, and I think Wayne said it yesterday as well. They are planning, but if you look back in the history, this has been planned for at least 6 years. So I don't know what is going to happen, but I think that they actually will do it eventually, because there's definitely value in this, because there's some information in the schematic that you don't have in the PCB. Okay. Or like if it's differential pair, for example, I don't know if I don't think it's available in the PCB. You have to get it from the schematic information. So it is definitely, me myself, I would like to see in which hierarchy it is, and at this point I can't get it, so yeah, it's totally supported.
You have one question about the requirement. Do the package are installed when KiCad is launched? I mean, you have some requirements, and if they are not installed in the system, do the plugin does not work or say an error?
In the requirements.txt file, for Python, what packages you need is
Yes.
yes. So if you're using packages in Python, it must be in the requirements file. And as I said earlier, unfortunately, it fell silently at this point. So if you don't have it in the requirements, it's just gonna fail and it's not gonna give you any feedback on it. And hopefully they will. Ah, right. I don't know. Yes, definitely. Yeah. I don't know exactly what time it's loaded. I think it's loaded when it starts up, but I'm not sure. I don't know if anyone else. Ah, yeah. Okay. Okay. So, TSI. Nice.
Do you know if it's possible to use the IPC API to raise DRC errors or warnings and maybe place DRC flags?
Well, I was wondering about it as well. As far as I know, not really. But obviously, you can write, if you want to do it as a separate step, I'm trying to plug in to do some checks. Let's say the space between the minimum space between two tracks. You can obviously load this from your PCB and then write your own Python code to actually calculate those distances. But I think it's a little awkward to do. But, yeah. And it also means that it's not going to go into your errors because you actually want it all to be in the same place. So, yeah. I think these things make a lot of sense because I said also thought about it. I think they're probably going to, as time goes by, that you can actually add, feed something back into the editor. You will. Sorry, just.
You have a command to make a DRC in the terminal, and then you can combine it with the IPC interface. So that's definitely possible.
Okay. But you do it through command line, correct? Okay. I didn't know that. Okay. Thank you, everyone.